So, I've noticed that constraints is a part of Blender that I feel like isn't being talked about enough. So, this video will be the start of a tutorial series on me explaining certain constraints and examples that I've used it for. You'll see timestamps on the bottom of the screen in case you want to skip anything. Alright, so for the constraints. The first one I have lined up here is the copy locations, a constraint. So in this case, I have the offset on. If I turn it off, it copies the location of this. If I turn on offset for this, it stays on the offset, but it also always follows it. Can be useful for a lot of things. Then you have copy rotation. So it doesn't move like this, but it can rotate. Currently have it on auto original, but if you set it to replace, it will only stay on this, but on after original it has an offset and like overlays it on top of it. Then you have copy scale, which just it just copies it. It does exactly the same. If you turn off the offset, it makes sure it's always the same scale. If you turn it on, then it's just again an overlay. And in this case you can also do power, so you use an exponent, so it grows double larger, so in the power of 2 in this case. Then you have copy transforms, which I'll set to replace, so it does all of them at the same time. So if I have it on auto original, does the copy location, does the copy rotation, does the copy scale, all at the same time. Then you have limit location. For this case I just set it just to the Y, so now I can only move it from 0 to 5.1 meters on the Y axis. And I have this cube parented to this, so if I put this on local space, now I can still only move it like this, but only on its local axis. So now if this parent is here, it should still work. So it's still only on this axis. Then you have the stretch to constraint, which I have this one parented to this cube, and it stretches like this. You stretch it to the other one like this. And I usually like to put the volume variation on 0. If you put it on 1, it actually like stretches it in all axes, which I like it just to stretch it. But one thing you have to keep in mind, like you see, it stretches further than that because the origin is here. So make sure the end of it is on its origin. So like this. It doesn't go further than its origin, which is usually what you want. Now the track to constraint, which just works like this. It's basically the same, but it doesn't stretch. One thing to keep in mind is most of the time you would want target C on. I can't really give a good example for this in this case, but I will show a better one later today. You can kind of see it here. If I move it like this, it just stays leveled. If you look at it, this stays leveled with the x-axis. But if I set target C, it rotates with it, which will be useful, but I will show that later on why it's that useful. Then you have the follow path. And you can animate the offset, so it animates perfectly along that curve. But then you have clamp 2, which makes you able to move an object over it, but it only affects the location and not the rotation or the geometry, which can be useful if you want to overlay a constraint with rotation afterwards, which you will see later on in this video. Then you have the shrink wrap, which I usually mostly use for automated suspension, since as you can see it always stays on top of the surface, which can be useful since that's what you want with suspension. That's it for the constraints I use the most. Alright, so here's example number 1, the train card. So basically what I want to do is make a rig that it would follow the curve, but the main point of it is that it follows the track. And why we have to make a complicated rig for it, or actually not too complicated, but more complicated than just a follow path. Like if you try out the follow path, as this happens when you do follow path, but then item 0, 0, and 0. I'll rotate it back like how it should have been. Like that. So if I do follow curve fixed position, follow curve, wait, I need to fix rotation again. And if you then animate the offset, then you can see it works, but not really, because what it does, it rotates over the origin. But then is the issue, the body is being affected, but the wheels aren't. So this one isn't touching the rail anymore, and this one is inside the rail. But that's not what we want. So I'm gonna explain how to get around that. Alright, so now that we've undone that, I'm gonna explain the principle of what I'm gonna do. So basically, what you wanna do is make sure the ends of or the wheels always touch this. So you'll have an axle and another axle somewhere with the wheels that always have to be. The wheels always have to be in this line, not go over that line. That's the most important part. And basically how you want to do that is to make sure the middle of the axle, so the origin of it, is always in the middle of the curve. So it's always following this part. And also for this. So what the body will then do is it will kind of overlap over this track. And here it will be kind of in the middle. Which is basically what happens. So how you're gonna make those origins so it always stays in the middle. Basically what you're gonna do is you put the 3D cursor on the axle, put an empty there, also an empty on this one. Just you can use any empty, but I like to use these ones. So if I or change the constraint to clamp to, you clamp them both to the curve. And what the clamp to constraint does is it moves them around the curve without rotating. That's basically what we want. We don't want them to have any rotation, because we're gonna add in the rotation with different constraints, so it does what we want. Otherwise it would have the same effect as the follow curve. So now that we have that, we're gonna go to the next principle, which is the rotation. Basically, what you don't want is, like the follow curve does, is it rotates like how the curve would be. So in this case, the rotation would be something like this. It would be rotated like that, but that's not what you want. You want it to point at the other axle. So that's basically what you want to happen. So that's gonna be very simple to do. Just by taking this empty, use a track 2 constraint. Just select this one, And now, if you're gonna make them go over this, as you can see, this empty always orients to this empty. And it's, as you can see here, it basically does what this arrow does and not what this one would do if it would be a follow curve. Alright, so basically all you have to do now, make sure all of it is parented to the middle object so that you don't have to parent all of them to this empty. That's just gonna make it easier. Then just basically parent this to the empty. So now with the body parented to the empties, all you have to do to animate it is just move both of them along the y-axis. And if you look at it now, all the wheels are aligned with the rails. Perfect. So let me just undo that, so it's back into place. Yes. So now because you're basically rigging, so an animator, or basically if you're making the project you, will have an easier time to animate. So basically what you can do now to make things even easier is add in an empty, whatever empty you want. I like to use a cube for these things. So it's kind of views the boundaries of the object. So it's easier to find and select. Now you select both of the empties, parent it to the cube, and this sometimes happens. Yes, I haven't found a way against it, but why this happens is because of constraints overlaying, but that's easy to fix by just moving that empty back to the origin of that axle and the other one as well. And then just move them back. Oh wait, I reversed them. Like that. So, perfect. So move it back into place. And now all you have to do is move this. And everything follows perfectly. So what you can do to make it even easier is add a limit location. And since you want to move it along the y-axis, check X and the Z. Now it will make this go back to its 0 point. That's not what you want. So you just keep tweaking with the numbers until it's perfect. Since it's still on 0, it's still close to perfect when you just add it on the meters. 3.3, something like that, 3.5. Just tweak till it's back in place, 3.8. Something like that, maybe just a little bit less. You can just go in between, like it doesn't matter much, it's just a visual thing. And then just move this back into place. 9, something like this. Looks good. So now you don't even have to press Y. You literally only have to move, and that's all of it. And one thing you might have noticed is this action happening. That's just basically when the curve ends. There's nothing you can do about that except by making the curve longer. So now the cool thing about these constraints is you can layer this effect. So if you just select all of this, even the empties, select that, Shift D, move it along y-axis, and select both of these. Add in a plane. Make sure you do this on a straight line, otherwise this wouldn't line up with both of these. And now all you have to do is basically the same thing. You add arrows or any empty, then you add another empty here, you parent the empty to the object. Then you parent this one to this object. Yes. Then you add the track to constraint to this one. And you parent this to this. And now you have these two ones. And if you move them, the train or the part on top follows it like a train would. So now it's more visible what the effect is actually doing, against a follow path. So it just goes in between the two. Okay, great. And if you want, you could also do the same as I did with the other empty. An empty. Yes, do that. Just scale it. And just parent them both to this, and again. Oh, this time this didn't happen. Last time it did, but yeah, so it's worked immediately when parenting. And now all you have to do is just move it, and again you could do the limit location if you want. Like, the limit location isn't necessary for anything, but it could be easy for person animating this and stuff. 3.7 something around that line, yes. Yeah, and then moving it up, yes. 2.5 around that. Yes, and now you only have to move it without the Y, and everything works perfect. Okay, so that's it for example 1. Alright, for this next example, I'm going to show you about double wishbone suspension. Double wishbone suspension works with two wishbones, which connects vertically to the wheel. So it has two wishbones which can rotate on the body, and there is a suspension piece here which just works as normal suspension, but it will try to compress these two down. So it will convert vertical movement to rotational movement. That's basically what you're going to do in this. So there's a few ways I thought of how to do that. As you can see here on the top, the curve, sinus and track 2. The first one I made is the curve. So you have an empty, you clamp it to the curve. So when you move it on the z-axis, it moves along this curve. So in that case, you have converted to rotational. So if you then place the axle or the wishbone and put a track 2 constraint, it will always follow this. So it will remain in this rotational movement. So if I move this down a bit, then this would be here. So basically this works perfectly, but the issue with this is because if you have a car or any object, you want to be able to move it and rotate it. This is just a very simple example of a car. So you want to be able to move it in any way because you want to have an animation freedom. But the issue with this is if you rotate the body where it's parented to, and you did set up the parents right, then this empty is trying to go up and down while it's rotating. Since if you have like a circle here and you have an empty here and you rotate everything, this also goes up on the z-axis. So when you have it here, then it's rotated, but this is also up on the z-axis, which means this is incredibly inconsistent. So when you rotate the car, this will also be in a different spot on the curve, which can mess with how everything works. So this one isn't an option if you want to be able to have freedom with rotating your car. So then you have the sinus. A sinus method is something that's used with a sinus wave in electricity. So basically, like in electricity, you have sinus waves, which look like this. So for AC electricity, so the way to calculate it is here is the vertical, since this is the amount of voltages. So this is the y, like that's how to say it, and then you can convert that to a degree of a circle. So how to do that? You calculate y with equals sinus alpha. So with this formula you can calculate this from the degrees, but you have to convert it since the controller will move vertically and you have to make it react in a degree. So I rewritten the formula like the opposite way, and I tried that in Blender in the drivers, but somehow it didn't work exactly how it should work. I'm not sure why it doesn't, but it is really inconsistent for some reason, and also I had to make some modifications to even be able to go around, so that's why it also is inconsistent, since the drivers don't work perfectly how normal formulas work apparently. So this one could be used, but you'll have to do a lot more research on it, because I wasn't able to find a way to make that formula work in the drivers. So then you have the track 2, which is the one I'm going to use for this one. So you basically have the controller again, and you have an empty and there an empty on the top, and both of the wishbones, they have a track 2 constraint to their empty. So if you move both of the controller down, because these will be parented to the controller, then these will track to those, and it will just work like that. The issue with this is that it would be inconsistent, since if you get lower down, this won't move further. So it will slowly go not go as far anymore, because this only moves on the z-axis. So this will just decrease in speed, which means it's not perfectly consistent and doesn't work perfectly. But the thing is, with a suspension of a car, you show it on the ground plane, because like if you have a body of the car, here's the suspension part. Like you can't make the suspension go further than this kind of, and you can't make it go further up than this. So you're kind of stuck in that, which means the inconsistency is so minimal that you just don't even see it. So that's why this one I found to be the most reliable for this. Now that I showed you the method I used for the double wishbone suspension that you see here, in the next video, which will be part 2, I will show you the steps of how I made this. It will be a part 2 because I don't want this video to be an hour long, so until next time, see ya!